Okay, kids, I'm going to pick up, just review a couple things we did today in class and just make sure that it's crystal clear. In 8.6 Law of Signs, the ambiguous case, we use the law of signs, but we want to determine there are situations where we have one triangle, we have two triangles, or we could have no triangles at all. And so in the first case, you can kind of see when you have one triangle, you're looking at when you have a fixed angle A and you have two sides like kind of in an L shape after the A. A is fixed, and those two sides are going to be B and A. When the opposite side is longer than B, as you can see there in the first case, then you're going to have one triangle. When the opposite side is equal to H, the height of the triangle, then you're going to have one triangle. In other words, again, angle A is fixed, that's height, and then the height is equal to A, and that's going to be shorter than B, but it's actually going to be equal to the altitude of the triangle. It's going to be a right triangle. Then the last case is when you have an obtuse angle and side A opposite the angle A, which is fixed, is bigger than side B. It's attached to the angle A. Okay, then you've got the two triangle possibility when the height is less than A and that's less than B. So with your fixed angle A, opposite A, you have side A. And you can kind of see what I talked about was a pivot point, that it could be the larger triangle, it could be that smaller triangle that you see to the left. So with that, the ambiguous case, you'll have two possible cases. And the way we do that is we get this red angle that you see here, and then we see, can we use the supplement to it with that linear pair as an angle as well? So that's what we try out. Then you have no triangle when the opposite side A, remember this is a fixed angle, A, and when the opposite side A is shorter than H, then it's just going to swing and it's never going to reach this baseline. And then the last one is when A is less than or equal to B. You can see when it swings the opposite side to this fixed angle here, it's never going to reach the baseline as well. It could be as long as B, but it's not going to make a triangle. Okay. And so I wanted to go through this first one. Let me get the bouncing ball here, so to speak. Not the bouncing ball, but let me see, where am I here? Okay, so if I look at this, I've got the steps here lined out for you. So we have one triangle in this first one because the opposite side is 45. That's longer than 24. So what's going to happen is you will have, this is the case where A is bigger than B in the first one. Even though you have an obtuse angle here, and scroll back up to it, it's this one. Okay, A is bigger than B. So that's going to be one triangle. So you just move forward. You recognize that you have the one triangle, and you use the law of signs to find B. You find B. Then you subtract from 180. You subtract 180 minus 112. And I said second answer because I had just gotten B, or you could just type in the B. So 180 minus 112 minus 29.6. And you get this answer. Angle C. So we have angle C. Now the only thing we have to do is then go back and use the law of cosines to find side C right here, the 30.1 that we found. So using the law of signs, I'm putting the angles in the top over sine A's in the bottom, and I get 30.1. You can see if you go through the steps here, and you guys are pretty good at you are really good at the law of signs. So, and then I list the three answers that I have for one triangle. Then moving on to the next one, it turns out that we have a two triangle possibility because we have A is less than B. You can kind of see this A is less than B. So when you look at this side, you can kind of see that in the second place, in the second drawing, I kind of pivot it over so we can be here. So if you look at that first case, here is my first triangle here, and here is my second triangle. And the middle triangle is just me playing around with it to show you that I can pivot the side A over so I get a different angle. But let's go with the first triangle first. You can see I walked all the way through it. I'm saying I'm going to find angle B, then I'm going to find angle C. So I use the law of signs to find B. I subtract my known angles from 180. Angle C is equal to 180 minus 38 minus 53.2, and I get an angle that's 88.8. I plug that in. And then part 3 is I'm going to find side C. When I find side C, I again use the law of sines, but I'm putting the sides in the top and the sine of the angles in the bottom. And so you can see where I work this out here. 1, 2, I get C is equal to 65. So, I think I have 17 there. I'm going to make that 65 here. 17 is down here, but 65.0, we'll write that as, okay. All right. So 65.0. And then, so now I have all the information for the first triangle. Then I'm going to go down to the second triangle. But notice I'm using this 53.2 to get, I'm using that, and I'm going to set up a linear pair where I have 53.2, and I just say, all right, well, 180 minus 53.2 gives me 126.8. So that's my new, I'm going to call it B prime. Then I move on, I see C prime. Where I get C prime, I just take the triangle degrees and I take 180 minus the 2 other angles that I have to find the unknown angle, and I get C prime is equal to 15.2. The last thing I have to find is side C. Side C turns out to be just 17.0. Okay, and again, using the law of sines, but again, stipulating that if you're finding a side, it makes it a lot easier on you if you just put the sides in the numerator, let the signs be signs in the denominators. Okay, so that's 2 triangles for the second example. Third example, if you recall that when we did that, we got sine A is equal to a quantity that's 1.72, and we get an error back in our calculator, which means that there's no triangle. No triangle. And so the thing about this is, picture that 51 has got to be shorter, and picture if I just draw it like this, what's going to happen is it's going to swing down. If that side B is less than or equal to, that's one of the third cases. The third cases, or it is, here it is right here. It is right here, no triangle. Okay, so if A, the opposite side, is smaller than H, in that case it is. And we could find H, but it's going to be smaller. We get sine doesn't exist there. So no triangles for this one. And then the last one, we had the cable problem where we just had to find what the angle was. And so we set up the law of sines with the green triangle. We don't really have to worry about the pole there. But we can just set up, in this particular problem, we'll just set up sine 39 over 50 is equal to sine C over 62. And I labeled them as such just to make it easier to match up the sides, the signs of the angles and the sides. Okay, and we got 51.3. That's it. I'm going to send this off to you guys in an update and hope you get that. Just to kind of review once more, I wanted to lay this out in a very precise manner for you, so you could see the order and the number of steps with that, okay? All right, I'll see you tomorrow. Have a great night. Bye.